Hi colleagues, welcome. This is Elim Kiganjani, and we will continue with mathematics coverage. We continue with Form 4 mathematics coverage, but we have been talking about area and perimeter as our main topic, and today's main focus is going to be on perimeter of a regular polygon. To remind you, in other videos, you can find them in this channel. We have been discussing actually areas and perimeters, and so far we have covered our area of triangle, area of trapezium, parallelogram, rhombus, rectangle, and square. And today's main focus, as I said, we are going to be here on a perimeter of regular polygon. So with perimeter of regular polygon, it's important to note actually what is a regular polygon. First of all, a regular polygon, we are talking of any polygon whose sides are equal and also their angles are equal, of course. So angles are equal and also sides are equal. That is regular polygon. So how are we going to find the perimeter of a regular polygon? We are going to consider a case in which we're going to see actually a polygon inscribed in a cycle. So with these details, the sum of the length of the side of polygon is known as perimeter. It means you take summation of all sides. For example, in this figure here, in the figure we have here, you can count actually the number of, you can count the number of sides, and we would say that perimeter, equals to 5s. Perimeter equals to 5s because one side is s unit. As I told you that we are going to consider a scenario in which we are going to have a polygon subscribed in a cycle, just like we see here a pentagon subscribed in a cycle. So we are going to derive the formula according to the inscription of a regular polygon in a given cycle. So we are going to consider one side of the polygon, any polygon now. So with this diagram here, these are the extension of the side of the polygon. So this is side, and this is also side, and this is also side. And n here is going to be number of sides, number of sides. And this angle here is going to be one of the angle theta. And angle theta, we are going to take a 360-degree divided by number of sides. So in the previous case, if we have to find the angle at the center here, with this case here, theta is going to be 360 divided by number of sides, which is 5, and we are going to have 72 degrees. But when we have number of side equals to n, it means now the angle is going to be 360 over n. So perimeter, I will call it P. Perimeter, calling it P, I'll be just taking number of side times the length of one side. I call it S, where S is the length of one side, where S is the length of one side. And we have said that n is going to be number of sides. So we are going to consider this triangle, right-angled triangle, and if I'm going to consider this angle theta here, focusing into right angled triangle, because this is isosceles triangle here. So half of this angle, you can consider it theta over 2. I'll be saying that sine theta over 2 is equal to opposite side, and this case is going to be AX over AO. And AX equals to actually side over 2. It means the side of the polygon divided by 2 over AO, which is going to be the radius of the cycle. So we could say easily that sine theta over 2 equals to S over 2R. And if I have to find actually the side of this polygon in terms of R and angle at the center, I'll be saying that S equals to 2R sine theta over 2. But we know that theta equals to 360 over n. So theta over 2 will be equal to, we'll be taking actually a half, equals to a half 360 over n, and eventually you'll be having actually 180 degrees over n, dear colleagues. So combining all these cases now, it means we can have S now equals to 2R sine 180 degrees, 180 over n, and this is going to be the side, the length of one side, and that is AB if I'm going to consider the diagram we have. But the perimeter is NS, so perimeter will be number of side times multiplied by 2R sine of 180 divided by n. So we get in actually 2nr sine 180 degrees divided by number of side. Mind you, that is the perimeter. So to conclude, you can say that perimeter of any triangle, any polygon, any regular polygon P is given by P equals to 2 and R. You have sine 180 degrees divided by n, and that is the formula we are going to have, dear students. But the fact that we know that 2R, this is equal to diameter, 2R equals to diameter, so the formula can also be reduced to perimeter equals to ND sine of 180 divided by n. This is just another formula we might be using to find the perimeter of a regular polygon inscribed in a cycle. So this is how we are deriving actually the formula of finding the perimeter of a regular polygon. So we are going to see examples. How do we solve the different questions you might be facing in this part? So one of the example we can have in this discussion, dear colleagues, I'll share with you one of the examples we might be having in this part. So here is one of the examples. Here is one of the example find the length of one side of regular 9-sided polygon inscribed in a cycle of radius 10 centimeter. So you can see the question. The question is find the length of one side of regular 9-sided polygon inscribed in a cycle of radius 10 centimeter. So with this question, we are looking for S. S equals to how much? But we were given actually number of side equals to 9. We were given also radius equals to 10 centimeter. Mind you, we got side equals to 2r sine 180 degree over n. So it means the side, one side will be 2 times r, which is 10. You have sine of 180 divided by 9. Eventually, we'll be having 20 sine 20 degrees. So we'll be just finding actually sine 20, and the sine 20, you plug the values, you are going to get actually the answer. So when you plug into your calculator, sine 20 multiplied by 20, eventually you'll be getting 20, you're getting 18.23. So the length of one side is equal to 18.260 centimeter. So that is the length of one side of a regular polygon, dear students. So I could say that length L equals to 18.260 centimeter. So that is one of the examples we could be having in this part. Another question we might be solving. So here the question is, find the radius of cycle which inscribes a regular hexagon with perimeter 50 decimeter. Hexagon, I think you know, the number of side of a regular hexagon is 60. So with this question, we were given actually perimeter equals to 50 decimeter and number of side equals to 60. We are looking for radius equals to how much? Remember, perimeter we said actually it is 2nr sine of 180 divided by n. So perimeter now, we were told that it is 50 decimeter equals to 2 times 60 times r, it is unknown, sine of 180 divided by 60. Continue solving. We'll be having 50 equals to 12r. You have sine 30 degrees, and sine 30 is a half. So we'll be having 50 equals to 12r times a half. Eventually, you have 50 equals to 60r. You simplify, radius will be 50 over 60 centimeter. To simplify further, radius will be 25 over 3 decimeter. This is also decimeter, dear colleagues. So that is solution for the second example we have there, dear colleagues. We can continue actually solving as many different type of questions as possible. Questions which are somehow giving you idea of how we can always actually deal with the cases of perimeter of regular polygon, dear students. I'd like to continue with the last example for this session, for today's session. And the last example, let us consider this question here. You can see it here, of course, yourself. So with this question, find the value of one interior angle of a regular polygon inscribed in a circle of radius 5 centimeter, given that the length of one side is 52 centimeter. So the length of one side is 52 centimeter, dear colleagues. The fact that the length is, not 52, it is 5 root 2, an apology. The length is 5 root 2. I have to make changes here. It is 5 square root of 2. 5 square root of 2 can be put in symbol there for the square root. So 5 root 2 is there, dear colleagues. So we are looking for the interior angle. We know that the interior angle will be 360 degrees divided by number of sides. So for we to be able to get this value here, of course, you need to know number of sides. So with the question we have, find the value of one interior angle of a regular polygon inscribed in a circle of radius 5 centimeter. We have radius 5 centimeter, and we are given the length of one side is 5 root 2. Length S is 5 root 2. First of all, we can have extension of any regular polygon, and I prefer to take this picture here. I will bring it here to this part so that you can find the connection of what we are discussing. So actually we are looking for this angle here. We are looking for this angle theta here. We were given now radius is 5 root 2 and S is 5 root 2. So we have seen that sine theta 2 over 2 is going to be actually a half of the side divided by radius. Half of the side divided by radius, dear students. So sine of theta over 2 is essentially side, it is 5 root 2 over 2, I could say, divided by radius, which is 5, of course. So it means 5 and 5 can be cancelling each other. 5 and 5 will be going, so that you have actually sine theta over 2 equals to square root over 2 of 2 over 2, dear colleagues. With this, we need to find now the acute angle corresponding to theta over 2, and theta over 2 will be sine inverse of root 2 over 2, will be getting 45 degrees. So theta now, interior angle will be 45 times 2, and you get 90 degree. So according to this question, find the value of one interior angle of a regular polygon. The value of the interior angle, one interior angle is 90 degrees, dear students. So this is the end of today's session. If it is your first time to be here, consider subscribing so that you're going to be updated on the content we're going to be uploading in the coming days. So until then, peace.